value of hands-on science has been described many times, and for anyone who's had the opportunity to sit in a lab like we just did and see it happening, you really see how much the students have learned, and they demonstrate it to you by showing you what they can do, and you see it in their faces and you see it in the way they solve problems. This is the point of this blog, is that sometimes it's difficult for parents who are not present during the hands-on activity in a lab like this or in a hands-on science program. The parents aren't there to actually have the benefit of seeing how much their students are actually learning by demonstrating it. And demonstrating it not only for their teachers, but demonstrating it to each other, and maybe even more importantly, demonstrating it to themselves, how much they understand and how adept they become at handling science and scientific problems. Okay, so I guess the essence of our blog here is that we have, as teachers, we have the ability to see the students in hands-on science education all the time. And it makes it easy for us to evaluate because we see constant examples and we see changes in students as the year progresses. Parents, not so. They don't get to come into the lab all the time. They can visit, but they don't see it every day. So here's the question. What do you, as teachers, do to try to make sure that the parents get to have an understanding of how their students are learning under conditions which they can't directly observe? On the other hand, I'd love to hear from parents of students that are in the LabLearner program or other programs where it's predominantly hands-on science instruction, and give us some ideas of ways that you can probe and find out what your students are learning under these conditions, even though you're not in the lab and you can only talk to them at home. And also, when we're talking about heat transfer, that heat always moves from an area of higher heat to lower heat. So in other words, you're going to have heat moving from a hotter to a less hot item. And we were doing that in this experiment that we were doing today in the laboratory that we saw here at JZU. So if we take this concept of heat transfer, now let's take it out of the laboratory and put it at the kitchen table. If the student puts a piece of ice in their mouth, or ice cream, so it's cold, and what happens is it melts. Okay, what's happening to the temperatures in the mouth? Two things are happening, and every student will identify this. One, the piece of ice is less cold, or it's getting warmer. On the other hand, something's happening to the mouth. The mouth is getting colder, sometimes even too cold. And what if we have the understanding that heat is always moving from an area of higher heat to that of lower, then we know that what's happening is that our bodies are actually transferring heat from our mouths, in this case, to the ice cube. And the ice cube now is going to increase in its amount of heat that it's absorbing from our mouths, and it then goes from a solid to a liquid phase, and we say it's melting, and then we swallow. When you can start to understand that kind of thing going on at the kitchen table, that is probably the best indicator that a child really understands the scientific concept. So we were discussing this a little bit earlier at the laboratory bench here, and one of the students said to me, so in other words, when we go outside in the winter and it's very cold out and we're coming out of the house and we're very warm, even though we're feeling cold, the cold's not being transferred to us. What we're doing is we're trying to heat up everything outside with our body. And I guess to some extent, we've made it a little bit warmer outside.
Brandy, Fortune to the office immediately.